The following content is created by Dr. Avitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below.
Welcome, ladies and gentlemen. In this video, we're going to be solving this very problem. We have to find the half-range cosine series of that very function. So we're going to be treating the function as an even function. Then we're going to solve. So first, we need to find a naught, because if it's a cosine series, you only need a naught and a sub n. So let's find a naught. So a naught is 2 over L. So we've got 2 over L, integral from 0 to L, f of x dx. So that's what a naught is going to be. Now what is L? L is half the period. But since we have the half range, so the half has been given to us as 4 already, because they've already taken the half of it. So L is 4. So this will become 2 over 4, integral from 0 to 4. Now f of x is theta squared. Oh, we're even dealing with theta, not x. So this will be d theta. So this is what we have. Next, 2 over 4 is a half. So this will become 1 half. And then let's integrate theta squared. To integrate theta squared, we're going to have theta cubed all over 3 from 0 to 4. Next, this 3 can come outside. We could actually bring it out. So this becomes 1 over 6. Then we've got theta cubed from 0 to 4. Next, this is 1 over 6. Now, anywhere we see theta, we're going to call it 4. So this becomes 4 cubed minus 0 cubed. So this is 1 over 6 times 4 cubed is 64. 4 cubed is 64. Now the 0 cubed is nonsense, so it's gone. Now 64 divided by 6. We could reduce that to become 32 over 3. So that becomes our a naught. That's a naught. Now let's find a sub n. Now a sub n will become 2 over L, integral from 0 to L, f of x, cosine of n pi x over L dx. But we know that our function is with respect to theta. So all of the x will go away and they'll be replaced by theta. So this is 2 over 4 because L is 4, integral from 0 to 4. F of x, which is f of theta, is theta squared cos n pi theta over L is 4 d theta. So that's what we have. Okay, now 2 over 4 is half. So this will be half. And then to integrate this function, we're going to use integration by parts. But it's a shorter approach to that. Let us write theta squared. So this is theta squared. Differentiate theta squared, we get 2 theta. Differentiate 2 theta, we're going to have 2. Differentiate 2, we're going to get 0, but that's kind of useless. So we're not going to write that. Now the cosine function, this cosine part, we're going to be integrating this. So to integrate cos, we're going to have minus sine, then put your angle n pi theta over 4 divided by, when you differentiate this angle, you will get n pi over 4. So this is n pi over 4. Close this up. Now this bracket, you're going to integrate it again for the next 2 parts. So integrate this again. So for a start, this is minus. So this will be minus. Integrate sine. We're going to get what? Hold on. If you integrate cosine here, you're going to have plus. Sorry, that's positive sine. Sorry, that's positive. So this sine here, when you now integrate sine again, this is minus cos. Then you put your angle n pi theta over 4 divided by, when you differentiate this angle, you will get n pi over 4. The n pi over 4 will make this n pi over 4 to become n pi over 4 all squared. Close this up. Now this whole bracket here, you're going to integrate it again. So for this next part, this is minus, we're going to write minus. When you integrate cos, we're going to have sine. Then we have our angle n pi theta over 4 divided by, if you differentiate this angle, you get n pi over 4. So the n pi over 4 will make this n pi over 4 squared, meaning we're going to have n pi over 4 cubed. And then the correct sign for this will be plus minus plus. And the interval is 0 to 4. Now, if you look at this correctly, the sine function would be giving us 0, because if theta is 4 for the upper limit, when you put 4 here, 4 over 4 is 1. 1 times n pi is n pi, and sine n pi is 0. Also, when you put 0 here, 0 over 4 is 0. N pi times 0 is 0. Sine 0 is 0. So everything here is 0. This one part is still 0. So it's gone. So the only one remaining is this middle. So this is 1 over 2 into minus times minus will give us plus. So that's 2 theta cos n pi theta over 4 divided by, when you expand this will be n squared pi squared over 4 squared is 16. 4 squared is 16. And this is from 0 to 4. So that's what we have. Okay, so these two will take care of these two. So they are basically kind of gone. So what will be remaining will be 1 over, now this n squared pi squared over 16 can come outside. So this is n squared pi squared over 16. The one will be left will be theta cos n pi theta over 4 from 0 to 4. Now I can bring out this over 16. I can take the over 16 to the top. So this becomes 16 over n squared pi squared. The one will be left will be this. But let us put in our limits now. So this theta will become 4. So this will be 4 cos. 4 over 4 is 1 because theta is 4. So this will be 4 over 4, which is 1. 1 times n pi is n pi minus theta again. This will be 0 cos 0. All right. Now, 16 times 4. This is because this part will give us 0, because 0 times cosine will just give us 0. So this guy is gone. So this is the only thing remaining. So this will be 16 over n squared pi squared times 4 cos n pi. Now, 16 times 4, this will be giving us 64 divided by n squared pi squared. Now, cosine of n pi is minus 1 to the power of n. So this is what we have. This is what we have. Now, we can now get our Fourier series. We can then get our Fourier series. Now, f of x, okay, so this is theta. So f of theta is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos n pi theta over L. So this is our what? This will be the formula for our function. Okay, so let's proceed. So this will be f theta equal to, now a naught is 32 over 3. So this is 32 over 3. Now, if you are dividing 32 by 3, and you also have to divide it by 2, so that means the 2 will join the 3 to divide. Then plus the sum from n equal to 1 to infinity. A sub n is this. So that's 64 divided by n squared pi squared minus 1 to the power of n. Then we have cos n pi theta over L. But L is what? L is 4. Okay, so f of theta will become 2 here is 1. 2 into this will be giving us 16. So we're giving us what? 16. So this is 16 over 3 plus, if you look at this, the 64 is a constant, the pi squared is a constant, so you can bring it out. So this is 64 over pi squared, then sum from n equal to 1 to infinity. What will be left at the top is minus 1 to the power of n divided by n squared cos n pi theta over 4. And this is what we have. So this will be your answer if you're asked to leave it in terms of n. But if you have to factor out, if you have to not factor out, if you have to write out some terms here, this will be 16 over 3 plus 64 over pi squared. Now let's list out some terms. So list out some terms here. Let n become 1. So minus 1 to the power of 1 is minus. It's minus 1. So this will be minus cos pi theta over 4. Because if n is 1, 1 squared is still 1. Minus 1 over 1 is minus 1. If you put 1 here, 1 times pi theta is pi theta. That's why we have that. Next, let n become 2. Now, if n is 2, minus 1 to the power of 2 will give us 1. So this will be 1 over 2 squared cos pi theta over 2. Because n is now 2, so I've simplified. 2 over 4 will give us half. Next, when n is 3, minus 1 to the power of 3 is minus 1. So this will be minus 1 over 3 squared cos 3 pi theta over 4. And then plus 1 over 4 squared cos pi theta. And then just like that. So this will become the answer to the equation. I kind of feel that there's a way you can deduce the series pi squared over 6 from this. But I've done that in earlier videos, so this will be all for this very equation. I'll see you in the next video.